In this example, we have a sprinter who accelerates for the first 4 seconds to a maximum speed. He then maintains this maximum speed for the remainder of the race. The question is, what is the average acceleration during the first 4 seconds? So we are given that the sprinter accelerates for the first 4 seconds. So let's draw a graph of velocity versus time. For the first 4 seconds, it accelerates. So in other words, the velocity should increase. But how it increases, we don't know. It's not given in the problem, whether it's a constant acceleration or any other kind of acceleration, we don't know. So we will simply make a sketch, an assumption that it looks something like this. Now, what is the actual shape of this curve is not known from the problem, and we don't really need it. So it accelerates to the maximum velocity, Vm. And then it maintains this velocity for the remainder of the race, and as is given in the problem, it just runs for 9.1 seconds. So for the first 4 seconds, he accelerates, and the rest time, it just maintains this maximum speed. It also says in the problem that the total length covered by the sprinter is 100 meters. So let's say that this is our L. In part A of the question, we need to find out what is the average acceleration during the first 4 seconds. Now, before we start solving the question, let's say that everything that has to do with this first 4 seconds will have a subscript 1. So this time interval will be delta t1. And the second time interval will be delta t2. And everything that has to do with the second time interval will have a subscript 2. So how do we find the average acceleration during the first time interval, delta t1? Well, by definition, the average acceleration is equal to v final in the first time interval minus v initial in the first time interval over the total time, which is delta t1. The final velocity in the first time interval is the maximum velocity that the sprinter gets to. So we can say that this is Vm. Initial velocity of the sprinter is 0 because it starts from rest. So minus 0 over delta t1. So we can say that this is just Vm over delta t1. We know delta t1, it's 4 seconds, but we don't know the value of Vm. So let's write down one more equation which has to do with the squares of the initial and final velocities for the first time interval delta t1. We can say that v final 1 square is equal to v initial 1 square plus 2 average acceleration delta x1. Now remember this equation which we've written here, and usually we will say this is one of the Suvat equations, which says that v squared is equal to u squared plus 2a delta t. It is the equation for a constant acceleration. Here the acceleration is not constant, but in our equation we are using average acceleration here, so everything works out. So we can say v final 1 squared equals v initial 1 squared plus 2a average delta x1. So v final 1 squared is vm squared. V initial is 0 plus 2 delta a, not delta but average a is vm over delta t1 and delta x1 is equal to the total length minus delta x2. So if this distance here is delta x1 and this is delta x2, then delta x1 is just the total minus delta x2. So I'll say L minus delta x2. But what about this delta x2? What can we say about delta x2? Well, delta x2 is equal to Vm times delta t2, because over the second time interval, the velocity is constant and is equal to just Vm. So delta x2 is equal to Vm times delta t2. So we can say delta x2 is equal to Vm delta t2. So let's take this and plug it into this equation. So we have Vm squared equals 0 to Vm delta t1 L minus Vm delta t2. After this, you just need to find Vm from this equation. Now, I would like to skip the algebra and just write the final answer for Vm. So Vm from this equation, and you can work it out yourself, is equal to L over delta t2 plus delta t1 over 2. If you then put the numbers in, the value that you get is 14.1 meters per second. So this is your maximum velocity, Vm. So now we are ready to calculate for the average acceleration. So the average acceleration is equal to 14.1, which is Vm, over delta t1, which is 4 seconds. And if you calculate this, you will get 3.53 meters per second squared. So this is the average acceleration of the sprinter during the first time interval of 4 seconds. Now, in part B of the question, we need to find out the average acceleration over the second time interval. And this is obvious. In the second time interval, the velocity is constant, so the acceleration is 0. Now let's calculate the average acceleration over the entire race. And this is part C. So in part C, we need to find the average acceleration over the entire race, which is 9.1 seconds. And we use exactly the same equation. Average A equals V final minus V initial over the total delta T. V final is the velocity at 9.1 seconds, which is Vm, so that's 14.1, minus initial, and we start from 0, so minus 0, over delta t, but in this case the delta t is the entire period of the race, which is 9.1 seconds. And this gives you 1.55 meters per second squared.